Hello once again, and we are now moving into the final part of dealing with other random formulas. And this time we are going to finally get into using identities to prove other identities. So let's go ahead and dive right in. Right, recognizing we've got double angle, half angle, sum product, product sum, some formulas, difference formulas, all these identities now, all these formulas at our disposal. It is now going to be our job to decide which ones to use when. So here's an example. Let's say I wanted to prove that tangent of x is equal to sine of 2x over 1 plus cosine of 2x. Let's say that that was true. It is, by the way, but let's say I wanted to prove it. Then it's going to be our job, and moving forward it's going to be your job, to decide which side to start with, what identities to use, how and when to use them, how to clean up what you get after the fact. That's going to be your job entirely. So maybe you saw this and you saw the sine of 2x, you saw the cosine of 2x, and you said, hey, well, if I just apply some double angle formulas, maybe I'll be well on my way. And you would be right? Taking sine of 2x be 2 sine x cosine x, that's great. But now we've got a cosine of 2x on our hands, and there's 3 different things you could substitute that for. Right? You could make that be, where was it? You can make that be cosine squared minus sine squared. You can make it be 1 minus 2 sine squared, or 2 cosine squared minus 1. Which one do you use? That's up to you. And I think it's possible to get where we need to go using any one of them, because they're all equivalent, right? It's just you might have to make the implicit substitution via the Pythagorean identity yourself to make it work out okay. But if you had chosen 2 cosine squared x minus 1 to be the value you wanted to substitute in instead of cosine of 2x, it actually will work out very nicely. The minus 1 and the plus 1 cancel. I've got 2 sine x cosine x over 2 cosine squared x. The 2's cancel, one of the cosines cancel, leaving with sine and cosine, which is tangent. So that is something you could have done. Recognizing I've got double angles, use the double angle formulas. But that's not the only way this could have gone down. Same example. You could have recognized, oh, look at the half angle formula for tangent. Half of something is equal to 1 minus cosine of the original something over sine of the original something, or alternatively, sine of that something over 1 plus cosine of that something. Well, wait a minute. If I just take this formula, this leftmost side and this rightmost side, and instead of u, I wrote 2x, I would have tangent of x, right, being tangent of 2x over 2. That's going to be sine of 2x over 1 plus cosine of 2x. And so really, if you had recognized that this was a half angle formula in disguise, there was no work to be done. Well, that said though, discovering that and making that realization is work in and of itself, but you can work smart instead of hard. You just have to do the work. And is that the only 2 ways this could have gone down? Probably not. You might have tried multiplying both top and bottom of this leftmost fraction by 1 minus cosine of 2x and see where that got you. That might have helped, that might not have helped. I would have gotten you just sine of 2x in the denominator, sine squared anyway. So maybe. No promises, no guarantees. But it's possible. And one last example. Just one quick, simple example, right? Your author likes to call things simple, but just because things are simple doesn't necessarily mean they're easy. So I want to prove that sine x plus sine 3x plus sine 5x all over cosine x plus cosine 3x plus cosine 5x is equal to tangent of 3x. You know, this one gave me pause. This one's not immediately obvious. And I mean that. It's not it does not jump out at you what you need to do, right? I've got double angle formulas, but I don't have triple angle. I don't have quintuple angle formulas. I guess I could make one just by doing sine of 2x plus x, sine of 2x plus 2x, and then break it down and break it down and break it down. But that would be so much writing, and I don't know if it'd actually work out in my favor. But what I do recognize is, okay, I've got sine of 3x here, I've got cosine of 3x here. If I just had sine of 3x over cosine of 3x, I would have tangent of 3x. So maybe I could just try combining the sine of the x and the sine of the 5x and the cosine of the x and the cosine of the 5x, and just hoping against hope that they magically disappear, right? Because if all this disappeared and all this disappeared, I would just have sine over cosine, which is tangent. So let's go for it. Let's just see what happens. Right? It's a very mathematical thing to just take a stab at what might work, see if it does or not, and see what we can learn from either our successes or our failures. So, sine of x plus sine of 5x. That comes out after using the summed product formulas. 2 cosine 3x times the cosine of negative 2x, which is just positive, right? Cosine's an even function. So I've got 2 sine 3x cosine 2x. Well, it's certainly not 0, right? This didn't just disappear. But, undaunted, we'll keep going. Cosine plus cosine via its sum to product formula is going to be 2 cosine 3x. Again, cosine of negative 2x, which is positive cosine 2x. So I've got 2 sine 3x cosine 2x over 2 cosine 3x cosine 2x. Well, they're not the same, you say. They don't cancel out. Well, bear with me. See it through to the end. Just because something doesn't look nice doesn't mean it's not going to work out. So I've got these two things instead of sine plus sine, instead of cosine plus cosine. So let's put them back into the equation, right? Sine plus sine 5 becomes 2 sine 3x cosine 2x. The cosine x plus cosine 5x becomes the 2 cosine 3x cosine 2x. And that's still being added to the original sine 3x and the cosine 3x respectively. And that's still not what I want, right? But I'm still not going to give up. Because now this numerator has a common factor, sine 3x. Factoring that out gives me 2 cosine 2x plus 1. The denominator has a common factor, cosine 3x. Factoring that out gives me 2 cosine 2x plus 1. And now, finally, these do actually cancel, leaving you just with sine over cosine, leaving you with tangent. And that is how you would go about proving something as scary looking as this identity here. Taking a stab at what might work and seeing if it does or not. And if it doesn't, well, learn from that. See what you might want to do instead. Just because something didn't work the first time doesn't mean it won't work if you try something else. A little bit of tenacity never hurt anyone. And really, that is what you will be doing in class, out of class, when you are proving identities in this section and going forward. It's going to be your job to decide, how would I go about showing this equation is always true? Which is going to help you very well in the future sections where we start looking with equations that aren't always true. Because then you would also ask yourself questions such as, well, how would I show that this is not always true? Or how would I show this is only sometimes true, and what values would I have to pick to show for that? So that is what we'll be doing next time. Although for those of you who are insistent on recognizing academic meta-analysis, this will be the last set of topics that you'll be tested on for test 2. So there you have it. There's your meta-analysis there. But hopefully you will keep this all in mind as we go forward, because it is going to matter. So I will see you next time. Have a good one.